Now with the core basics, or with the getting started section out of the way, let's dive into the core TypeScript syntax, the core features. And that of course means we'll dive into the types, which types TypeScript offers and supports, and how we work with these types, how we assign types, how we can reap the benefits of using types, and all that fun stuff. TypeScript provides many types to JavaScript. Now, JavaScript itself also knows some data types, and I'll come back to that in this module as well, but TypeScript adds many more types. And as you will also learn in this course, TypeScript also enables you to write your own types. Now, let's start with some of the core types which JavaScript already knows and which TypeScript also supports. And we'll also have a look at what the difference between JavaScript knowing the type and TypeScript using that type means. One of the core types we work with in JavaScript and TypeScript is the number type. Now in JavaScript, and the same is true for TypeScript, there is only one number type. There is no special type for integers or floats. Instead, these values here would all be numbers. One would be a number without a decimal place. 5.3 obviously is one with a decimal place. And all these values are of type number. Other programming languages have special integer types and float or double types. JavaScript doesn't have that, and TypeScript doesn't have it either. So we have the number type, which we know from JavaScript, also as a type in TypeScript. We also have the string data type, and that would be text, which you can define in one of these three ways, with single quotes, with double quotes, or also with backticks. The last notation with backticks is a special syntax provided in modern JavaScript and also in TypeScript, which allows us to write so-called template literals that are normal strings where you can dynamically inject some data into them. So strings are simply text, and JavaScript knows about string value types. TypeScript does so as well. Last but not least, one of the core data types JavaScript knows and TypeScript also supports is the Boolean data type. That would be true or false, and that's super important in programming, obviously, especially when working with if statements. Here we got these two values, and that's important because in JavaScript you also might know this idea of truthy and falsy values. For example, that 0, the number 0, is a falsy value. If you use it in an if condition, it is treated as false. The Boolean data type really just knows these two values though, true or false. And that's not just the case for TypeScript, but also for JavaScript. This truthy falsy concept, which you should know, that is not related to data types. That's some behind the scenes work JavaScript does at runtime when it sees certain values in if conditions. So with numbers, strings, and booleans, we got a couple of core data types. Of course, not all. We got objects and so on as well. But let's focus on these types and see what TypeScript does with them, or what we can do with them with the help of TypeScript. For this, I'm back to the project we saw in the first course module. And there I showed you that all you need to do now is run npm start in a terminal, navigate it into this project folder to spin up this live development server, which will reload whenever we change something. And here I opened up this localhost 3000 address in a new tab of my browser. Right now I'm getting an error because I have no app.js file yet. Of course, you find this starting project also attached to this lecture. We'll get such an app.js file, which we're trying to import here in our index.html file, as soon as we compile app.ts from TypeScript to JavaScript. And we can do that in a new tab of the terminal, so that we keep this process running and open a new tab instead, by simply running tsc app.ts. And what this does is it compiles the TypeScript file and spits out a JavaScript file. And once that happens, we can reload this page and we get the time to get started output here. So now we have this setup here where we can write some TypeScript code and then compile it to JavaScript code to see what it does. Now with that, in the TypeScript file, I'll actually get rid of the content there because now I want to dive into these core data types which I just showed you on the slide so that you understand how to work with them in TypeScript. Now let's start very, very simple. Let's say we have a new function, add, and there we expect two numbers and one and add two. and I return n1 plus n2. Just like that. Very simple function, nothing TypeScriptish about it. Now we have two numbers with which we want to work. That could be number 1 here, which is say 5, and also number 2, which is maybe 2.8, whatever you want. Two numbers here. Now obviously, and not very surprisingly, we can add or call the add function and pass in number 1 and number 2 as arguments to this function, store the result in a new constant maybe, and then to see something on the screen, we can console log the result. If we do that, and I recompile this file with tsc_appts, then this page should automatically reload already. If not, you can manually reload, of course, and you should see 7.8. Now, you might think that's not too special, right? This is a pretty straightforward JavaScript snippet, and indeed, there's nothing TypeScriptish about it. Well, let's do something which will break that snippet in normal JavaScript. Let's say this input here is actually not a number, but some text. A 5 in text. And if we now save that and rerun our compilation command here, you'll see that once this page reloads here, I get 52.8 as output. And that's obviously not the correct result of this addition. Now, do you know why we're getting this output in normal JavaScript, which we in the end are executing here? Well, we're getting this output because this is not the result of the mathematical addition, but instead this concatenates this as a string because this input here, 5, is a string. And then JavaScript sees, okay, I got a string, I'm adding something to the string. Well, certainly this something should also be converted to a string so that overall I got a string because the first value was a string. And hence what JavaScript does is it converts 2.8 from a number to a string, concatenates a longer string from 5 and 2.8, hence yielding 52.8 as a string, and returns that. So it's not treating this in a mathematical way, but instead as a string. And with JavaScript, this can happen. Now, of course, you might think, why would I write such code? I'm the developer. Why would I make this mistake? Well, maybe you're not the one making this mistake. Maybe this is getting fetched from some user input, and you introduced a little bug in your code where you forgot to transform this. Or you're working in a team and you're having a couple of script files working together and some other developer introduced such an error. It's not impossible to make such errors, but it can be hard to track them down. Here, of course, it's pretty obvious that something went wrong because we have a basic script, but in a bigger script, you might not even immediately recognize that something went wrong here. And that's where TypeScript can help us. We can add type assignments in this function to our parameters. We can tell TypeScript that these two parameters should be of type number and not be of type I don't care, which is the default. So we do that by adding a colon here after the value to which we want to assign a type. So in this case, after the parameter name, and then the name of the type. For example, number would be one of the supported names. Besides number, you also got string or boolean, but we'll come back to those. For the moment, we need number. And we don't just need it on the first parameter here, but also on the second one. So here also we can add a colon and then number. And now what we're saying to TypeScript is, hey, both parameters here should be of type number. Passing in values of a different type is not allowed. And indeed, my IDE already complains here because Visual Studio Code has built-in TypeScript support. But even if we would overlook this, as soon as I recompile this by rerunning tsc_appts, you'll see we get an error. We get an error that argument of type string 5 is not assignable to parameter of type number. And it even shows us where this happened and gives us the line number, line 8. And it's basically showing us the same the IDE shows here. So in case we overlooked it in the IDE, compiling it now throws an error. And that's the important thing about TypeScript. It only helps us during compilation. It doesn't change JavaScript to work differently at runtime because browsers have no built-in TypeScript support. It can only help us during development before we compile our TypeScript code to JavaScript. But there, it's extremely useful because it adds an extra step, an extra sanity check, where here we find out, oh, we made a mistake. Here, this shouldn't be a string, this should be a number. And we can fix this and we're good. This is what TypeScript does. It helps you during development. It does not change your runtime code. Indeed, here, even with the default settings, it compiled our error here, even though it detected it during compilation, and created a file which causes the incorrect result. Because by default, TypeScript does not step in here. Later, you'll learn how you can make sure that it does. But by default, it doesn't even block compilation. Still, it yells at you and points at this mistake, so that you can fix it and so that you can avoid such mistakes here. By the way, make sure you don't have app.js and app.ts open at the same time. You could get errors here in the IDE regarding duplicate function implementations. Closing the JavaScript file fixes this. So we already see how TypeScript can help us during development. Now, we also know that there is a number type in JavaScript, and we can see it with the built-in typeof operator. This is now not TypeScript specific. This is a built-in operator and keyword supported by JavaScript. We can use it to get the type of a certain value. So here we could console log type of number 1. And what we'll see if we do that is that as soon as we compile this so that we run the updated code, here we print number to the console. Now we do that thanks to this output here and thanks to the typeof operator. And in vanilla JavaScript without TypeScript, we could use that to also improve our function here. We could check if type of number is equal to number, type of n1 I mean, if that is equal to number, and we could also check if type of n2 is equal to number, and only perform our operation here if it is, and otherwise throw an error, or do the opposite and check if it's not equal, or if n2 is not equal, and if either of the two is not a number, then we could throw a new error where we say incorrect input. This actually would be a non-TypeScript way of ensuring that we can't call this function with a string here. If I do this now and I recompile, we get our TypeScript error, but let's ignore that for now. If we rerun this, we get the incorrect input which we're throwing ourselves. So now we hardened this function in JavaScript. It fails at runtime, but failing might here be better than showing an incorrect output, which we had before. So this would be a way of checking the inputs in just JavaScript. You don't need TypeScript for that. That's regular JavaScript code. But of course, this approach has downsides. Sometimes it's the right thing to do. Sometimes you only can validate certain inputs at runtime. But the downside is here, we're checking something which we actually can avoid during development with TypeScript. So yes, we're throwing an error, and in our application, we might have built-in measures that can then fall back to some other behavior to save the running application. But still, we're throwing an error which is really not necessary to occur in the first place. We could have prevented it with TypeScript. And here we really see the difference between JavaScript and TypeScript when it comes to types. JavaScript is dynamically typed, which means it's perfectly fine that we have a variable which initially might hold a number where we later assign a string to it. And that's why we have the typeof operator so that we can check the current type of something at runtime if we have some code that depends on a certain type. TypeScript, on the other hand, is statically typed, which means we define the types of variables and parameters and so on during development. They don't suddenly change during runtime. Now, of course, since TypeScript is compiled to JavaScript, they theoretically could, but if we use TypeScript and we write code where we suddenly assign a new type of data into a variable, where we previously set that this should be a number, for example, and now we're assigning a string, then we get an error during development so that we are forced to be clear regarding the types something can or cannot hold. That's the difference here. So we don't really want to use implementations or solutions like that if we can avoid it with TypeScript. Still, it's important to know that JavaScript, of course, knows about the concept of types. It knows about some types like number, string, and boolean. But using that always means that we can only fail at runtime instead of during development, which is a better place for us as a developer. It allows us to fix bugs earlier. And in addition, JavaScript only knows about a couple of types. As you will learn throughout this course, TypeScript knows about way more types than JavaScript. So this runtime checking is really not as flexible or not as powerful as what we can do with TypeScript. And for all these reasons, this approach is actually not the approach we want to use here. Sometimes it can be useful to get the type at runtime, but sometimes, like in this example, it's way better to get it during development. The only important thing to recognize, of course, just is that with TypeScript, you only get the support during development, not at runtime, because these TypeScript features and checks are not built into the JavaScript engine, so that logic can't execute in the browser. It can only execute during development when you compile your code. So now that we know about TypeScript fundamentals and how it differs and also is related to JavaScript, let's dig a bit deeper into the different core types TypeScript knows. The number is the type we see here, and as I explained, there is no difference between integers, like the 5 here, and floats or doubles, as it would be called in other programming languages, like the 2.8 here. Indeed, in JavaScript, and the same is true in TypeScript, all numbers are floats by default. So for JavaScript, and therefore also for TypeScript, there is no difference between 5 like this and 5 like this. It's the same number, essentially. Now, besides numbers, we also have other core types, and that would be strings, so text, and booleans. So let's also have a look at those. We actually saw all of those in action here in this if statement already, which we learned is a bit redundant. Nonetheless, this here would be a string. Also, of course, 5 with quotes would be a string because it's text. And the result, for example, of this comparison here, that would be a boolean. This operator, the triple equal sign, or the negated equality operator here, that produces true or false. And of course, we can either produce it dynamically in a if check, which we'll often do, or we initialize a variable with a true or false value. So let's do both here. Here we could add a new constant, print result, and set this to true, for example. And just to make it really clear, this could be a variable as well. It doesn't have to be const, it can be a variable, which you would create with let in JavaScript. But since I don't plan on changing it here, I'll go with a constant. And we could pass this as a third parameter here. Let's say we pass in print result, which holds true here. Now, we immediately get an error, of course, because our add function does not support a third argument. We see expected 2 arguments, but got 3. So therefore, we have to make sure we support a third argument. And there we could add a show result parameter. You could name it print result here as well. I'm going with show result to avoid confusion regarding the naming, but technically these two names would not clash. So here I'll name it show result. And I want to make sure that this is of type Boolean by setting this to Boolean. Again, by adding a colon after the parameter here, and then by adding the name of the type. Now this function accepts this, and now what we can do is we can add a if check here and check if show result. If this is true, we can of course compare it to true, but as you know in JavaScript, you can also just pass in the truthy or falsy value here, and JavaScript will evaluate it. And if this yields true somehow, or a truthy value in general, then we'll make it into the if block, otherwise we won't. And let's say we do make it in here, and then I want to console log n1 plus n2. Otherwise, in the else case, if we don't make it in there, then I want to return this. So now this is a function which sometimes returns a value and sometimes does not return a value but output it immediately. Now, you could argue if you want to write such a function which is kind of unpredictable or which might behave unexpectedly if you're passing in true here. But here we're doing it. So this function only sometimes returns, sometimes it also does not return, but instead just logs something to the console. Now here we can actually call add just like this and don't need to store it in result and don't need to console log result, because with print result set to true, add itself, so the function itself will print the result. Hence, if we now save that and we recompile our app.ts file here with the tsc command, once this is done, the page will reload and we still see our output here, but now it's coming from line 6. And if we have a look, line 6 is indeed inside the function. So this is a Boolean. Now let's say we want to customize the output, and therefore we have a result phrase constant here where we say result is colon and then some white space, and we pass that in as well with result phrase here, well, then we could expect this as an argument here as well, phrase, which should be of type string, by adding a colon, and then string is the name of the type. And now we could use that phrase to output it as part of our result output if we're printing the result right in the function. So then here we could have phrase plus n1 plus n2. And if we do that and we recompile by repeating that command, we'll see that this phrase is part of the result. But we also now reintroduce the old bug. Because I have a string which I combine with two numbers, everything is converted to a string here. And that's not what I want. To avoid this, in this function, we could add a result variable here, or a result constant, and store our result here. This will now be treated in a mathematical way because only numbers are involved. And then here we could combine that with phrase or just return it. And now, since this is never directly calculated together with a string, this will always be a number. And yes, then here this number combined with a string will be converted to a string. But since the mathematical calculation finished before that, we'll have the right result. So now if we repeat that and I recompile, we get the right output. So now these are the core data types in action. Let's now make sure we fully understand how types are assigned and also why we don't explicitly assign types down there. So we're using the core types of number, boolean, and string. And here in the list of parameters of this function, we're always explicitly assigning the types with a colon after the parameter name and then the name of the type. So here the names are number, boolean, and string. And in case you were wondering, these are now special identifiers. This overall here is a special syntax which is added by TypeScript. It's not part of the compiled JavaScript code. If we check that code, here these type assignments are gone because JavaScript does not support them. This colon thing after a variable or after a parameter, and then number and boolean and string, these special keywords, this is introduced by TypeScript. The TypeScript compiler understands it. The IDE here supports TypeScript and therefore doesn't complain about these special keywords. JavaScript does not understand this syntax. It doesn't understand a colon after a parameter or a colon after a variable and then the special number or string keyword. JavaScript doesn't understand this, and therefore this is not part of the JavaScript output. It's really just used by the TypeScript compiler, and then, well, it is a compiler because it converts this code to JavaScript code. Side note, you also see it switches const for var, but that's something I'll come back to later. So we have our explicit type assignments here, and it's only understood by TypeScript. Great. Why don't we have them down there? I don't have explicit type assignments here, and by the way, also not here when we calculate the result, for example, because TypeScript has a built-in feature which is called type inference. This means that TypeScript does its best, and it does a pretty good job there, to understand which type you have in a certain variable or a constant. And here, for example, it understands that number 1 will always be of type number in the end because you initialize it with a number. Now, this actually is a constant, so it's even more specific than that, and the type it identifies here is not just any number, it's the number 5. Because you'll not be able to assign a new number or a new value to a const value anyways. If we would change this to a variable, so if you would use let instead, then of course this would not break anything. We can use a variable there. It might not be best practice because this value never changes, but it's also not horrible. But now if we hover over this, we see TypeScript doesn't say, okay, this has to be a 5, but still it detects that the type here is a number. Now we absolutely could write this code here on our own. We can add a colon after the variable name on the left side of the equal sign, and then the name of the type. So basically the same we did in the parameters of this function. But this is redundant, and it actually is also not considered to be a good practice, because TypeScript is able to perfectly infer this type from there. So assigning this is not a good idea. This only changes if you would create this variable in an unassigned way. Like this, if you don't initialize it immediately. Then it's a good practice to tell TypeScript which value will eventually be stored in there, so that when you later assign a value to it, and of course it's a bit redundant here to split this in 2 lines, I'm just doing this for demo purposes, but now if I assign this here, this works because I told TypeScript in advance that this will be of type number. You don't have to do that, it also works if you don't do that, but now you could also add this 5 and you wouldn't get an error, because you're not telling TypeScript anything about the type which will be stored in this variable, and therefore TypeScript allows any type. If you instead add :number here, you're telling TypeScript, hey, eventually a number will be stored in there, and hence if you later store something else in there, like in this case where we store a string, you'll get an error here in the IDE, and of course also if you compile your code. You will get the error we already saw before. So this is how you can assign types. Now, even if TypeScript just inferred a type, and let me fix this, it will yell at you if you break that inferred type. Actually, it's wrong to say even, because of course it does. Why would it not do that? Type inference is there for you to save you code, to avoid that you manually have to assign a type. Of course, TypeScript yells at you if you then use a wrong type, a type that it did not infer. For example here, if result phrase is created with let, so that it's variable, then TypeScript here infers that this will be of type string, because we initialize it with a string. So this is basically the equivalent to not initializing it and setting the type on our own, and then assigning a value later. Now if we change result phrase to, let's say, 0 here, for whatever reason we might want to do that, well then we get an error here, that type 0 is not assignable of type string. And that makes sense, right? TypeScript inferred that we want to store a string, we're now trying to store a number, we get an error. That's the job, the core task of TypeScript, checking types and yelling at us if we're using them incorrectly. Let's dig deeper into the core types TypeScript supports. The next type that's interesting is the object type. Now, you know objects in JavaScript, they look like this. You have curly braces and then you have key value pairs in there, and such values would also be treated as object types in TypeScript, so any JavaScript object is of type object, though I will already say there are more specific versions of objects in TypeScript, so that you can say this is not just any object, this is an object which has to have these properties, or which has to be based on this or that constructor function. But we'll get there step by step. To dive into objects, I'll first of all rename app.ts here, and I'll rename this to basics.ts here, and add a new app.ts file, which will then overwrite the old app.js file once we compile it, where we can now dive into objects. And let's start by creating a basic object here, let's say a person with the curly braces here, and we give this a name. Here I'll go with Maximilian because that is my name, and the age of 30. Now, of course, we can console log person here, and if we do so, and we compile this, unsurprisingly, we should see that object being printed here in the console. Now, what we also can do in JavaScript is we can try to access, let's say, nickname, a property which does not exist here. Now, you immediately see that TypeScript is not too happy about that, and hence my IDE tells me. It tells me that property nickname does not exist on that type. So if we save that, and I try to compile that, we indeed get that same error down there. The TypeScript compiler does not like this, and it tells me that we have no nickname property on this object. It finds out that we don't have this nickname property because if we hover over person, it inferred, we can see there is a colon after person, so after the variable or constant name, it inferred that this is the type of data which is stored in there. Now that's not just object, as you can tell, that is a concrete object. It's an object with a name key, where then the type in turn has to be a string, and the age key, where the type has to be number. And actually this can be confusing here. This here obviously looks like a JavaScript object, curly braces, key value pairs. Well, the first important thing to see here is that we have a semicolon here after each line. We don't have that in a JavaScript object, we have a comma here. And indeed, this is not a JavaScript object here, which is created somewhere. This is the object type inferred by TypeScript. And object types are written almost like objects, but of course we don't have key value pairs there, but key type pairs. Object types are there to describe, well, the type of object that is getting used somewhere. We could be more generic. I could explicitly assign a type here to the constant of object. Object is one of the built-in types, just like number and string. And now if I hover over this, we see persons of type object. And now TypeScript really only cares about the fact that this is our object type. Now still, if we compile this, we get that error though, because TypeScript still analyzes our code and sees that we try to access something which doesn't exist there. But it's important to understand that it all starts with this most generic object type. But often you want to be more specific than that. You don't just want to work with that generic object type. You really want to get the full support. For example, right now if I add a dot here and I have a look at my auto-completion, I get no help there at all by my IDE. Reason for that is that all we tell the IDE is that we have a value here in person, which is of type object. Indeed, now we actually also get an error if I try to access name. Name exists here, right? But what we tell TypeScript here is that we just have an object where we don't give any other information to TypeScript. So actually TypeScript doesn't support any type of property because we don't tell it anything about the object. So we should be more specific. And we are more specific by setting a specific object type, the thing which TypeScript also inferred automatically. We do this by adding curly braces here after the colon, after our const or variable name. So this here does not create a new JavaScript object. This will actually be stripped out of the compiled JavaScript code. Instead, this is just TypeScript's notation of a specialized object type, so to say. So of an object type where we provide some information about the structure of the object. Now, by assigning just an empty pair of curly braces as a type, we essentially do the same as with object. We tell TypeScript that this is some object. Now we can be more specific though. We can add key value entries here, however, not key value, but key type instead. So here we could say the object which should be stored in person should have a name property, and the value of that name property should be of type string. So here we describe the type of value which will eventually be stored in name. Now, by the way, you see I'm getting an error here, because what I'm telling TypeScript now is that my person should have an object with exactly one key value pair where the key is name and the value of that key is string. But we then assign an object with two key value pairs. Name, which holds a string, that is fine, but age, which holds a number, and that would not be fine. So here we have to adjust this by adding a semicolon and then adding another key value pair here where we say age should be of type number. So not 30 here. That actually would be supported in TypeScript, that we restrict it to one specific number, but then we'll run into issues as soon as we change that. Instead, here I just want to say age should be some number. And now we basically are explicitly assigning the same TypeScript inferred before. As you learned, that's not a good practice, but to understand object types, I wanted to do it here. Still, this is something you can do. It's better to let TypeScript infer this as we did before, like this. Now, just to show something interesting, if I switch back to the suboptimal code, where we explicitly assign a type TypeScript would be able to infer, if we compile this code, of course, it works, we can access the name property, but if we then have a look at app.js, we see this type assignment is removed here. And that, of course, should be something expected. As I mentioned, types and type assignments are not part of JavaScript. They're TypeScript only. I just wanted to show this again to make it really clear that this syntax here is not creating some JavaScript object which is somewhere in our code. This is just TypeScript's representation of an object type that helps TypeScript understand the objects you're working with. The better syntax, of course, is this syntax, as you learned. Now, besides objects, we also have arrays in JavaScript, very important type of data. Arrays are created like this in JavaScript, as you know, and you can store any data in there. Numbers, strings, booleans, objects, other arrays. You can have nested arrays after all. And you can also mix data. You can have an array with strings and numbers mixed. And TypeScript also supports arrays. Any JavaScript array is supported, and the types of that array can be flexible or strict. Now let's have a look at that in TypeScript. For that here in app.ts, let's say our person also has a hobbies key. But of course, we could also have a variable or a constant hobbies outside of the object. So using arrays is exactly the same inside of objects and outside of them. So here we have hobbies, and hobbies could be sports and cooking, let's say. So I have two elements in there, and these elements, as you can tell, are strings. Now, if we hover over hobbies, TypeScript correctly detected that this is of type string array. Now, that's a syntax you haven't seen before, but this is how TypeScript describes an array of data. You have the square brackets, and in front of that, the type of data which is stored in there. Now, this is the type TypeScript inferred. It saw that here we have an array and that we only have strings in there, so it inferred that hobbies probably should be an array of strings. And indeed, for hobbies, that makes a lot of sense. Of course, you can also explicitly set the type of a variable. If we would add a new variable, favorite activities, and initially that should be empty, then we might wanna explicitly set the type of data stored in there. And now let's say that should be an array of strings. Well, then we can just repeat what we just saw. Type string, and then square brackets thereafter. And this tells TypeScript what we store in here is not just a single string, it's an array of strings. And indeed, if I try to store just sports in there, I get an error. I get an error because that here is a single string and not an array of strings. I don't get an error, of course, if I wrap this into square brackets, and therefore effectively I create an array. I again do get an error though if I add a number, let's say, because we defined this to be an array of strings. Now here we have a mixed array. It's an array of strings and numbers. So that does not work and is not supported here. If we would want to support such a mixed array, one solution would be to use any here. The any type is a special type in TypeScript, which we'll have a closer look later, which basically means do whatever you want. It's of course a type you don't want to use too often because you'll lose the benefits TypeScript gives you. You're back in JavaScript world, where you also can use any value anywhere. So any is really flexible, but the flexibility comes at the price of basically giving up all benefits TypeScript offers. So here I want to go back to string because I really don't want to have a number in there, and hence we can remove the number and we're good. Arrays also give us a great example, actually just like objects and their properties, how dynamic TypeScript's type inference is. If we add a for loop here at the bottom, and we want to go through all the hobbies of person, we can of course use a traditional for loop with for const hobby of person.hobbies, so accessing the hobbies property and going through all the hobbies there, storing each hobby for each iteration in this constant, and then we can console log hobby here. Now that's not too fancy, that's something we know from JavaScript, right? If I now compile this app.ts file down there, we get the name from this line and thereafter the two hobbies being printed. But what's actually interesting here is that on hobby, we can access anything we can access on any string. For example, to uppercase. I get this auto completion and TypeScript does not complain. Why does it not complain? Because it knows that hobbies is of type string array. So when I access person.hobbies, TypeScript's inference detects that hobbies will be an array of strings. So hobby, on the other hand, is correctly identified as being a string, because since we go through an array of strings, well, the individual values have to be just strings. And therefore TypeScript offers us great support down there and allows us to do anything with hobby that can be done with a string, because it knows with certainty that hobby will be a string because of the types we set up there. And that's really flexible and of course a great feature which makes writing code a lot easier and way more flexible and secure. For example, we would get an error here if I would try to access hobby .map if I thought this would be an array. The map method is available on arrays, but not on strings. And here correctly I get an error that map does not exist on type string because it doesn't. So here we get an error, and that's good that we get it, because this would be wrong. And here we see TypeScript's inference really shine. So arrays are supported, and with numbers, strings, booleans, objects, and arrays, we got the core values or value types JavaScript knows supported in TypeScript. As you will learn at the example of objects and arrays, TypeScript even offers way more functionalities there, but that's a bit more advanced, which is why we'll have a look at that later. But even these core types, with what you'll learn in the previous lectures, are supported. Now, TypeScript also adds a couple of new concepts, new types, which we don't know from vanilla JavaScript. For example, the tuple type. Now, you might know tuples from other programming languages. JavaScript does not have them. This is a tuple, for example, and you would say, well, this is an array. It is an array, but it's a fixed length array, and actually not just fixed length, but also fixed type. Now, where could this be handy? Let's say here on our person, we actually have another property, role, which is an array with exactly two elements, where the first one is, let's say, a numeric identifier, like 2, and the second one is a string identifier and a human readable description, like author. Now, this should always have exactly two elements, because a user or a person in this application, which we're writing, let's say, can only have one role, and a role is only made up of two elements. Of course, we could have used an object here, but for some reason we want to have an array with exactly two elements, where the first element always is the numeric identifier, and the second element always is the string identifier, or description, or however you want to call it. Now, if we hover over this, TypeScript actually infers this strange type, which we haven't seen before. Effectively, this means TypeScript understands that we have an array which might hold either strings or numbers. This is a union type, and we'll dive into those later. The key takeaway is that TypeScript understands that this should be an array with these types of values. The downside is that we could run this code though. Person role push admin. Now, for our application, this might not make sense because we know we only need two elements. Still, TypeScript doesn't know that we only want two elements. We would also be able to switch person role, the second element with index 1, to be a number as well. This would work because TypeScript only knows that role should be of type string or number array, and therefore assigning a number here to the second element and therefore replacing it with a number would be allowed, because we're just saying something about the types we generally can use in there. We know we want to have exactly that structure. Two elements, first element number, second element string, but TypeScript doesn't know that. Well, for such a scenario, a tuple would be perfect. We can tell TypeScript what role should be by explicitly setting the type of role. So here we also have an example where TypeScript does infer a type, but we explicitly want to override it. Now here we can therefore add an explicit object type by adding a colon after person, then the curly braces, and then name should be a string, age should be a number, and hobbies should be a string array. So all as inferred by TypeScript. So for that, we wouldn't have required this explicit assignment, and as you learned, it would have been bad. But now we have a scenario where the inference does not work in the way we want. And we want to set role to be a tuple. Now, instead of setting it to string array or number array, or using the same type that was inferred here earlier, we can now use a special type. We use square brackets again, but now inside of the square brackets, we add number, and then a comma, and then string. Now, this marks a tuple type here. A tuple is a special construct TypeScript understands. In JavaScript, it will be a normal array, but during development with TypeScript, we'll get errors with code like this here. Now, what do tuples do? This here tells TypeScript, I want to have a special array with exactly two elements, because I have exactly two types in there, and the first element should be a number, the second element should be a string. Hence, if we compile this code here, I get an error regarding 10 not being assignable as a type here, because we want to have a string as a second value. And if I then assign 10 as a second value here, then I obviously don't follow this rule. Now, if we comment this out and we compile, this works. That's a bit strange, because why does pushing work here? Because we're also saying that role should have exactly 2 elements. So why can we push admin onto the role array here? Push actually is an exception, which is allowed in tuples. So unfortunately, TypeScript can't catch this error, but at least it ensures that we're not assigning a wrong value here. And outside of push, we also get some support regarding the length. If we set person.role to a new value, for example, an empty array is not allowed. One with exactly the structure we defined up there is allowed. If I added an extra element here, then we would again get an error. So the length is enforced if we assign it like this, but not for pushing and so on. This is something you have to be aware of. But still, getting this support and this support is pretty nice. And if you have a scenario where you need exactly X amount of values in an array and you know the type of each value in advance, then you might want to consider a tuple instead of an array to get even more strictness into your app, to be even clearer about the type of data you're working with and the type of data you're expecting. Loosely related to the idea of a tuple is the idea of having a couple of specific identifiers, global constants you might be working with in your app, which you want to represent as numbers, but to which you want to assign a human-readable label. And for that, you have the enum type. Again, that does exist in some other programming languages. JavaScript doesn't know it, though. It looks like this. This is how you create an enum. You use the enum keyword, which only exists in TypeScript world, not in JavaScript. Thereafter, you have curly braces and then your identifiers. And this type, which is added by TypeScript, gives you an enumerated list. So these labels are in the end just translated to numbers starting at 0, where you have human-readable labels you can work with in your code. To show you an example, let's go back here to our person with its role. I'll copy that code and then comment it out because I'm going to change it a bit. And then here, I'll get rid of that explicit type assignment and instead go back to inference because I'll now change role. And now let's say we want to have an admin, an author, and maybe a read-only user. The admin should have an ID of 0, read-only user has 1, author has 2. Now, of course, we can store that exactly like this with these numbers. One downside is that we can also add a number for which we might not have a role. And if we then later in our code try to extract a role and use an if check, this might lead to errors. And in addition, we as a developer have a hard time to understand which role this user has. Was 2 the author or was it the read-only user? You might forget this after making longer pauses, when working in bigger teams, and so on. So as a developer, we might want human-readable identifiers, something like admin and read-only user, something like that. Now, of course, we could use that. We could work with such string values. The problem is if we then later need that in an if check, we check if person.role is equal to, was it read-only user or was it one word? Was it with underscores? You see, then we have to remember how we wrote these strings, which exact text we have in there. Because this string with the dashes between the words is of course not the same as this string. So here we would never make it in there. Is read-only if we try to compile and print that, because, well, the check simply doesn't yield true. We don't have that as a role on person, hence we don't get the output here in the console. So string identifiers also have downsides. Now for such scenarios, it's quite common in JavaScript to define global constants, for example admin, which then hold certain values like numbers or strings. Both is possible. Numbers, of course, can save us some extra code and bits in memory. And there we might have admin, read-only, and author like this. And down there, we then just have to use that role. Now the advantage of that is that we can use this everywhere in our code. And therefore here, for example, if I run this code, if I compile it, and then we let this reload, we see is admin here. So this works, and this is a common pattern in JavaScript. Downside is that now again, role is inferred to be just a number. So we could store any number in there, even a number which we don't support. And in addition, we have to define all these constants. We have to manage them. This is where an enum can save us work. This is totally fine, but an enum makes it easier. We create an enum with the enum keyword. We can name it role. Convention is to start with the uppercase character because an enum also is a custom type. It's your first custom type. You're going to write many more in this course. This is the first one. And then after the name of the type you want to assign to this enum, you add curly braces, just like that. No colon, no equal sign, just curly braces after the name. Then a semicolon. And now in here, you can assign your values like admin, read only, and author. And behind the scenes, this here receives the number 0, this here number 1, this here number 2. And then here you can access role.admin, like on an object, you access your identifier, and you can use that anywhere else in your code as well. Here we can check if the role is author, and then print author. And of course, we shouldn't see that if I run that now because we assigned a role of admin here. But the key takeaway is that we did all of that with the help of the enum, which assigns labels to numbers. If we have a look at that in JavaScript, so in the compiled code, we see this is how it's rebuilt. In the end, it's rebuilt with a iffy here, so a function which executes itself. And role here simply is managed as an object in the end, which has an admin property, a read-only property, an author property, where we then store our number values here, you could say. So it's a bit more complex than that, but that's what TypeScript in the end does here to replicate this enum construct in JavaScript code when it compiles the code. Here as a developer, we simply have these conveniently created numbers. If you hover over them, you see the number which was stored in there, and you can use these numbers here in a human-readable way. Now for enums, you're also not restricted to the default behavior. Let's say for some reason you don't want to start with 0 as a starting number, then you can add an equal sign here after your identifier and enter any other number, and now admin is assigned to the number 5, and the other identifiers after the identifier where you assign a value pick up on that and simply increment this starting value. So now we have 5, 6, 7 instead of 0, 1, 2. You of course also can assign your own values to all these identifiers if you need your own numbers. You're also not restricted to numbers. You can also go with text here or even mix it like I'm doing it here. Anything goes there, but often the default of incrementing numbers that start at 0 is what you want. But if you need a different behavior, if you want to use a string in here and then a number here and here a number as well, or maybe another string, then you can absolutely do that. The advantage is you define it up there, and then thereafter you always just refer to your role type, to this custom type you created, to this custom enum you created, and you use that in your if checks and your type assignments, and you're good. That's the power of the enum, and it's a great construct whenever you need identifiers that are human readable and have some mapped value behind the scenes. With that, we're almost done with the core types. There is one more type which we already saw, and that's the any type. The any type is the most flexible type you can assign in TypeScript. This type doesn't tell TypeScript anything. It basically means you can store any kind of value in there. We got no specific type assignment. TypeScript will basically never yell at you when you use any. Back in our code here, if I would set the type of favorite activities to any, would not get an error. If I set it to any array, I at least tell TypeScript that favorite activities is an array of something. So if I would store just a single value in there, I would get an error. But as long as it is an array, I can store whatever I want in there. So any is really flexible, and this can sound great at first, but actually it's a big disadvantage, and you absolutely want to avoid any whenever possible, because any takes away basically all advantages TypeScript gives you. It gives you the same experience you have with vanilla JavaScript, where you also have the any type on everything, so to say. Any basically makes sure that the TypeScript compiler can't check anything, because if any property or any variable can store any value, well, then there's not much to check, right? So you can use any as a fallback if you have some value, some kind of data where you really can't know which kind of data will be stored in there, and where you then maybe are using some runtime checks, like we did here, at runtime to narrow down what you want to do for certain values. Then you could go with any. But in other cases, you really want to avoid any. If you have a chance of knowing which kind of data you're working with, be explicit about it. Let TypeScript's inference do its job, or explicitly set your own types. Don't fall back to any if you don't need to. So we covered a couple of the core types TypeScript knows. Now let's move on. And for that, I'll rename app.ts here to objects, arrays, enums, or whatever you want to name it, basically so that we still have that file, but I'll create a brand new app.ts file so that we have an empty file again in which we can work. Now in this file, I want to dive into another interesting type which you find in TypeScript, and that's the union type. Now what's that? Let's come back to our add function which we wrote earlier. I'll copy that and move that into app.ts, get rid of that comment here. And here on add, let's close basics.ts so that we get rid of that error. Here in add, I now want to be more flexible regarding what we accept here. I will also get rid of show result and phrase. I don't need that. And the only thing I want to do is I want to calculate a result and return it, but I want to be more flexible regarding the inputs. Previously, we made sure that we only work with numbers. Now let's say we actually name this combine, and it should work with both numbers and strings, because it turns out we can combine both numbers and strings with this plus operator. The only difference is that in one scenario we get back a number as a result, in the other scenario we get a concatenated string, as we actually already saw earlier in this module. But now I want to allow this behavior, because you could have an application where you want to have a flexible combination function that does work with numbers and strings. Therefore, I will also name this input 1 here and this input 2 and combine these two now. But we will have one problem, of course. Right now, we set both parameters to be numbers. This means that we can call this function as long as we do want to work with numbers. Let's say down there we're creating a new constant, combined ages, and there I call combine and pass in 30 and 26 here as ages in whatever application we're building, and I thereafter console log combined ages. Well, it shouldn't be too surprising that if we now compile this file here, and we then reload this page, we get 56. So this works, we get this number. But of course, we have a problem if we try to create a string here. Combined names, for example. If I try to combine Max and Anna here, then, well, we immediately get an error here that Max is not assignable to type number, because this, of course, is a string. Now, of course, we could change this to accept strings instead of numbers, but now the first function call would fail. And that is where union types can help us. If we have some place in our application, be that a parameter of a function or a constant or a variable we're using somewhere, where we accept two different kinds of values, well, then a union type can help us. To tell TypeScript that we are fine with either a number or a string, we use number and then the pipe symbol here, and then the other type we also accept. And you can have more than two types. You can accept as many types here as you need. So here I only need two though, and that's therefore the type assignment I'll go with, number or string. Now I get an error here that the plus operator cannot be applied to type string or number and string or number. That's actually not entirely correct. This should work because we can use the plus operator with both numbers and with strings, but TypeScript only sees that we have a union type here, and it doesn't analyze what's in the union type. It just sees, okay, you're expecting multiple types, Maybe that includes types where I can't use the plus operator, hence I will complain here. Now, thankfully, we can work around that issue though. We can add our runtime type check here and see if input1, if the type of that is equal to number, and if the type of input2 is equal to number, and then move this calculation in there. Now just one improvement. Let's create result as a variable outside of that if check because of block scoping, so that this is a variable available in the entire function, and then just assign a new value in there. So now here we check if we do have two numbers. And therefore TypeScript knows that in here, input1 and input2 both will be numbers. Now let's add a else check here. And there we can set result equal to input1 dot toString, explicitly converting this to a string, and input2 toString. And this will then also be fine for TypeScript and JavaScript because we can concatenate two strings. So now we have almost the same calculation, but we make clear that here will always work with numbers, here will always work with strings, and then we return the result. And now with that, if we console log the combined names down there, and we compile this file, we'll see that once we revisit our page, we got the combined numbers there, which were simply added together, and hence we get a number as a result, and the combined names here. So this is how we can use union types to be more flexible regarding what we do in a function, for example, or anywhere else in our code. This extra runtime type check will not always be required when you work with union types, but often it will be, because with union types you can be more flexible in, for example, the parameters you accept, but then you might have different logic in your function based on which exact type you are getting, so that your function is able to work with multiple types of values, but that it then does slightly different things depending on the type you're getting. So often you might need such a runtime check when working with union types, but you'll not always need it. You will certainly also encounter situations in TypeScript programs where you can use a union type without a runtime type check. It really depends on the logic you're writing. So now we got union types here. Let's build up on that idea of union types and also introduce literal types. Literal types are types where you don't just say that a certain variable or a parameter should hold, let's say, a number or a string, but where you are very clear about the exact value it should hold. We saw that early already, here in basics, const number2, for example. There, if I hover over that, you see the type which was inferred is not number, it's 2.8. And TypeScript did infer this concrete number as a type here because it's a constant. It will never change, and therefore TypeScript knows the value I assign here is the exact type I have. So of course this is a number. You could say 2.8 is derived from the number type, but it's a specific number. And this does not just exist for numbers, but also for strings and so on. And especially for strings it can be very useful. Let's say here in our combine function, we expect numbers or strings and we combine them differently based on what we get, but we also want to allow the caller of the function to define how the result should be returned, so that we can basically force a conversion from number to string or the other way around. We could do this with a third parameter, and we could name that, let's say, result type or result conversion, or however you want to name it. And I want to describe this with a string, so I'll set this to type string. Now my idea is that I can call combine here with two numbers, and for example pass in a string of as number. And it's totally up to you which identifier you use here. Down there we might have as text, but then we might have another combination here, combined string ages, where I pass in two strings, but I still want to output this as number. And this would be a case where the third parameter can be helpful to force a conversion. Because if I pass in two strings here, normally we would make it into this else branch and concatenate it. And I might want to return this as a number instead, so that I can also console log combined string ages here. So now we just have to take these identifiers into account in our function by including result conversion in our if checks. Now the question is, what exactly do we want to do? Do we want to make sure that we can force these two strings to be added as numbers? Or do we want to force the result, no matter if it was a mathematical calculation or a string concatenation, to be converted to a text or a number? If we want to force a conversion, we could add the if check here and check if result conversion is equal to as number. And if that's the case, I want to return result with a plus in front of it, which converts it to a number. The alternative would be parse float, for example. But here I'll just go for the plus, since this is a bit shorter. And else, I want to return result to string to force an output as a string. So now we do the calculation based on the real type we get, but then we convert the result. That's one way of doing that, and if we save that and we then compile this file, we see this is the result I get, and we get that output, for example, for our string combination here, because, as I said, the combination itself, the calculation, so to say, is performed based on the type we feed in, which here is a string, so we concatenate it, and then we just convert the result. The alternative logic would be to check the type here and do a different operation based on the return type we're specifying here. So we could comment this out and instead here say if the type of input 1 is number and the type of input 2 is number, or if result conversion is equal to as number, then I want to combine values like this. And now to avoid this error, here I force the conversion to numbers by adding a plus in front of each input, so that each input is converted to a number and is guaranteed to be a number before I combine them. Side note, if you would pass in strings that can't be converted to a number, so something like max, for example, then you'll get NaN, not a number, as a result. Well, and in the else case, so that we don't have as number or that we simply don't have number inputs, then we make it into this block here. And now with that, if I return result again here, and we then save this and recompile, we'll see a different output on our page. Now we get 56 in these two lines here, because now we're not converting the result, so we're not converting the concatenated string for this line, but instead we're doing the conversion before we combine the two values. So that's up to you which logic you want to implement. I actually want to have a closer look at the literal types concept, which I described at the beginning of this lecture. I'm passing in as number and as text, and the downside of this is that right now we as a developer have to memorize these values. We have to make sure that we don't mistype here. Now we could use a enum to improve that, but if we only have two values here, as text or as number, then maybe also such a literal type could be an option. We could say this shouldn't be any string, it should be as number or as text. So we use a union type combined with literal types. Literal types are the types which are based on your core types, string, number, and so on, but you then have a specific version of that type. So here we allow specifically these two strings, not any string, just these two strings. So we want a string for result conversion, but it has to be one of these two values. Any other string value will not be allowed. So that's the idea behind a literal type. And often you will use this in the context of a union type, because you don't just want to allow one exact value. You could hard code it into your code if that would be the case, but you want to have two or more possible values. In this case, we got two possible values. So now we are guaranteed to get result conversion, which is either as number or as text. And for example here, if I now try to compare this to as num, because I have a typo here, TypeScript is able to tell me here in the IDE, and of course also if we save it and compile it here in the terminal, because it knows that as number without a R at the end will never be a valid value for a result conversion, because I set this union type with these literal types. So now we again gain some extra type safety and ensure that we can't use this incorrectly. The same, of course, for passing in a value. If we have a typo here, we get an error. Only if we use either as number or as text, we're allowed to compile this. As you see, if I now compile this, this works, and we get the same output as before here. So these are literal types, especially useful when used in conjunction with union types. Now, when working with union types, like this and this, it can be cumbersome to always repeat the union type. You might want to create a new type, which in the end stores this union type. And you can do that with another cool TypeScript feature, the feature of type aliases. You create such an alias, typically before you use it, so here at the top of the file in this case here, with the type keyword. Now the type keyword is not built into JavaScript, it's supported in TypeScript though. And after type you add the name of your custom type or of your type alias, I should say. For example, combinable, but the name is really up to you. You can invent any name here which is not built into JavaScript or TypeScript as a key name. So something like date would not be allowed because that's built into JavaScript, but combinable is not built into JavaScript, not built into TypeScript, so we can use it. And now with the equal sign, you assign the type you want to encode in your alias, so to say. So we could store a number here, and now whenever we want to make sure that something should be a number, we could use combinable instead. Now, that doesn't make too much sense. It arguably would even make our code harder to read. If I use combinable down there, for example, this would work technically, but if we just glance over our code, it's not obvious that here we want a number or a string. Well, typically, therefore, you use that in conjunction with union types. So we can store a union type in our custom type, so to say, in our type alias, and now just refer to combinable down there instead of our union type. So we have exactly the same setup as before, we just have our reusable type alias here, which we can use instead. And that allows us to save some extra code and make sure we always refer to the same types or the same type setup when we use combinable. And of course, we cannot just use that for number and string, we can use that for any type setup we might want to store in an alias, including these two literal types, for example. So for these two types here, for this union type, we could also create a type alias, conversion descriptor, or however you want to name it, and store exactly this type in this type alias. And now we can use this type alias down there. So type aliases are really useful. You can encode more complex type definitions into your own types, into your own type names, so to say, and reuse that everywhere in your code where you need exactly this type setup, so that you avoid typos down there, and you can simply save code, write code quicker, and also be clearer about your intentions, for example, by choosing descriptive type alias names up there. Time for another new file. I'll rename app.ts here to union aliases ts and add a new app.ts file where we can start from scratch again, close the other file. And now in here, I want to dive a bit deeper into functions. Now, of course, we already worked with functions, for example, here in the union aliases file with the combine function. And for example, you saw that for functions, you can assign types to the parameters of functions. Well, turns out there's a bit more you can do with functions and types. For that, I'll recreate my add function, which simply accepts numbers, not strings, which does one simple thing. It returns n1 plus n2. So not too tricky. Now, as I mentioned, we can assign types to parameters. That's not new. The function overall, however, has one important other type. It has a return type. And here the return type is inferred by TypeScript. We can see it if we hover over add. Here at the end, the colon after the parameter list, this here describes the return type of the function. So the type of the returned value. Here I return the addition of n1 and n2, and since both these inputs are numbers, TypeScript is able to infer that the result of this will be a number, and since we return it, that the return type of this function therefore will be a number. If we would concatenate them as strings here, with toString for example, then TypeScript would correctly infer that we return a string here. Now, of course, we can also explicitly assign a return type here by adding a colon after the parameter list and then the type you want to return, like number. This would be the same type as inferred. If I, for example, set this to string, I would get an error here because obviously my calculation here does not match my described return type. Now, just as with variables, it's a good idea to let TypeScript do its job regarding type inference. And if you have no specific reason for explicitly setting the type, you should therefore not set the type and instead let TypeScript infer the type. Regarding the return types, though, there is one interesting type which we haven't seen before and which might be brand new to you if you have no experience with other programming languages, because it is a type that doesn't really exist in JavaScript. It's the void type. Let's say we have the print result method. There we get a number argument, which should be a number. And in there, I want to console log num, and I want to console log it as part of a string where I say result plus num. So now this will be concatenated to one long string and will be output. And now I can call print result and, for example, pass to that the result of my add function call with 5 plus, let's say, 12. So I'm executing add here with two numbers, and the result of that, so what add returns, is then passed as an argument into print result, and that should print it to the console. If we now compile this and then have a look at that in our page or on our page here, we see result 17, which makes sense. Now the interesting thing here is the return type of print result. What would you guess is the return type here? So maybe you think it's string because I'm creating a string in here, but keep in mind we're not returning this. We're not returning anything here. And therefore this print result function here has a special return type, void. Now you might know this void return type from other programming languages. There you have something like this. JavaScript doesn't really know that or doesn't really have a name for this situation. TypeScript, however, does. So indeed, this function here has a return type of void. And of course, you don't need to specify it here. TypeScript's inference did its job. But I want to make it really clear that this has the void return type, which is why I am adding it here for demo purposes. Now, void really just means this function doesn't have a return statement. It doesn't return anything. It successfully completes, it does its job, it executes its code, it does not yield an error or anything like that, but it then does not return anything. That's the void return type. Now, technically in JavaScript, of course, if we would console log the result of print result here, and I now compile this and we see what gets output here on the page, we see that undefined is returned by that. So technically, and that's really interesting, in JavaScript, if we use the return value of a function that doesn't return anything, we get undefined as a value. And as you probably know, undefined in JavaScript is actually a real value. A value you, for example, also get if you try to access a property on an object which doesn't exist. So here we get void, even though technically this returns undefined. And now to make it even more confusing, undefined actually is a type in TypeScript. You can have undefined as a type, and for example, a brand new variable, some value, can receive undefined as a type, and you will not get an error. This variable will now just be forever undefined. How useful that might be is a different question, but undefined is a valid type in TypeScript. Nonetheless, here you see we're getting an error. And we are getting an error because a function is not allowed to return undefined. Technically, it of course does, but TypeScript thinks about functions a bit differently. You should use void here if a function returns nothing and not undefined, because with void you make clear that this function deliberately does not have a return statement. If you would say undefined here, then TypeScript would expect that you have a return statement where you just don't return a value. That's the technical difference. Now you see I'm not getting an error. From a JavaScript perspective, this is basically the same as this, but TypeScript makes a differentiation here, and therefore void is the type you want to use if you don't have a return statement. Undefined, which you will rarely need to be honest, can be used if you return without returning an actual value. But again, this is a rare use case, and you could use void with a return statement like this as well. You would not get an error, and by default you would actually also use void in this scenario, unless you really have a function that should produce undefined and you want to be clear about that. But again, that will rarely be the case. I just want to make sure here that you understand the difference between void and undefined, that void is the standard which you'll use in pretty much all scenarios where you have a function that does not return a value, and that you can assign it explicitly, but of course TypeScript also is able to infer it, like it would be able here as well. I just added this for demo purposes here. So you can use types for function parameters and for the return value of the function. Now, to take it to the next level, what if there also were a function type itself? Now let me make it clear what I mean. Let's say we have a variable, combine values, and this variable by default has a type of any. Now, as you learned, any is not that useful. What I want to do eventually is I want to set combine values equal to add. So I want to store the add function, a pointer at this add function, in combine values, so that in the end we can console log combine values and execute combine values as a function to which I pass 8 and 8. Now if I save that and I execute this after compiling it, so if we compile this file and then we let this reload, we get 16 here. So that works, and we would expect it to work because that is normal JavaScript code. We can store a pointer at a function in another variable and then therefore execute this variable as a function because, well, it points at that function, right? So we can execute that function through that variable. The problem we have with this snippet here from a TypeScript perspective just is that combine values is any. So if I set combine values to a number here thereafter, of course, we can compile this, unfortunately, because TypeScript has no chance of detecting that this is unwanted or that this could cause a problem. But at runtime, we would get an error, because obviously we try to execute combine values as a function when it actually is a number. Now we want to avoid this, and for that we need to be clear that combine values will hold a function. Now a first step into that direction is that we set the type here to function. Function is a type provided by TypeScript in the end, and this makes it clear that whatever we store in here has to be a function. Therefore here I'm getting an error because 5 is a number and not a function. And if I comment this out, we can compile this, otherwise we would get an error during compilation, and now this again runs as expected. So that's good, but it's not perfect, because now we say this should be a function, but it could also set combine values equal to print result, for example, here. And of course, TypeScript would not complain because print result is a function, but of course, it's not a function that takes 2 arguments. So again, if I compile this, TypeScript will not complain, but if we reload, we see undefined here and result 8. So I don't get the result I want because I stored the wrong function in there. Again, it would be nice if TypeScript would tell us about that. TypeScript can't inform us about this because all we said to TypeScript is that we want to store a function in there, and this is clearly the case. So it would be good if we could be more precise regarding how the function should look like that we want to store in combine values. And that's where function types come into play. Function types are types that describe a function regarding the parameters and the return value of that function. A function type is created with this arrow function notation you know from JavaScript, or at least close to that notation. You don't add curly braces here because we aren't creating an arrow function here, we're creating a function type instead. Now on the right side of this arrow, you specify the return type of the function you eventually want to be able to store in here. And that should be number. Now with that we're saying combine values accepts any function that takes no parameters and then returns a number. Now that's of course not entirely what we want. We want to make sure that combine values takes a function or is able to store functions that take two numbers and return a number. Now for that we can add parameters here to this function type. We don't have to match the parameters names from up there, just the types. So we could have A, which should be of type number, and B, which should be of type number. And now what we're saying to TypeScript is that combine values should accept any function that takes two parameters, where each parameter is a number and where the function overall then returns a number. And that's why TypeScript does not complain about us storing add in combine values, because add is a function that perfectly satisfies this type definition. But it does complain about print result, because print result, as it tells us here, is a function of type one argument, which is a number, nothing is returned, whereas we actually expect to get a function with two arguments, where each argument is a number, and we also return a number. So we have a mismatch here, and if I would try to compile this, we therefore would get an error here, of course, in the compiler, and we only can fix this by removing this line of code. Now we are able to recompile this without errors, and now this runs as expected. So function types allow us to describe which type of function specifically we want to use somewhere, be that an expected value in a parameter, if we create a function with some callback, or like here, a variable. Now speaking of callbacks and function types, there it works pretty much in the same way. Let's say we have a new function up there, add and handle, let's say, and there we expect to get two numbers. And then I also want to get a callback function here, so a function which is passed in as an argument that should do something with the result. Then here we could generate the result, of course, but now I'm not returning it, but instead I want to call the callback function and pass in result. Now for that I want to be really clear that callback should be a function, so again I'm using that function type definition, that maybe does not return anything, but that does take a number as an argument, because we're passing in a number here. So the callback function, the function we're passing into this function as a parameter, should accept a number. And now down there we could call add and handle, pass in 10 and 20, and then pass in a function, for example an anonymous function here. So now here when we call the function, this is of course not a function type, but a concrete value we're passing in for this third argument. So this now here is an anonymous function I'm creating here. And there we know we'll get a number, maybe name it result here, and then we can do with it whatever we want. And now if we compile this, we see this log down there, 30, which is the result of our callback function, which we pass to add and handle, where add and handle combines the two numbers and then calls the callback, where the callback has to meet this condition here. The advantage of us defining the callback function definition here is that inside of the function we pass in as a callback, TypeScript is able to infer that result will be a number, and hence we could do anything with result here, what we could do with a number, without explicitly stating the type here. Because TypeScript knows result will be a number, because we made it really clear that the callback will get one argument, which is a number. Hence, also if we would expect a second argument here in the callback, we'd get an error, because we know, well, the callback we expect in our add and handle function only should have one argument. So if we then pass in a callback function which takes a second argument, that clearly is a mistake. The only thing TypeScript does not pick up is if we return something here. If I return result, then the callback does return something, even though we made it clear that it shouldn't return anything. This, however, is not a mistake or a bug in TypeScript, it actually happens on purpose. By specifying void here on our callback type, we're essentially saying we'll ignore any result you might be returning here. So we're basically saying in add and handle, where we get that callback function, will not do anything with the return type. That's why you'll be able to return something here without punishment, but you know, because it's clearly defined here on the callback type, that the callback will not do anything with the value you might return here. So that add and handle inside of the function will not do anything with that value you might be returning. And that's of course a useful piece of information. You might expect that in here we're doing something with the value returned by the callback. And by specifying this type here, we make it really clear that inside of add and handle, we're not interested in any return value. So this does not force you to pass in a callback that does not return anything. It just tells you that anything you might return will not be used. For the parameters, it's of course different. There, this is enforced, because here it really matters that you know if you're passing a callback that expects more parameters, well, then you'll get an error or you'll not get the result you want because I only give you one result. So there we can't just ignore what you might want, as it's the case for the return type. We can ignore that here. For passing something in, the add and handle function is responsible for that because that's where the callback gets called. This is why parameters are enforced, and TypeScript is really strict regarding the number and type of parameters of callback functions, and why it doesn't really care about the return type. We're almost done with the basics about TypeScript and the core types. There are two more types which are good to be aware of because they will matter from time to time. And the first type is the unknown type. For that, I'll name this file here functions.ts and add a new app.ts file. And in there, let's say we have a new variable, user input, and this is of type unknown. It's not of type any, which would be the default, but unknown, which is a different type introduced by TypeScript. It might be unknown because we don't know yet what the user will eventually enter. If it's a number, if it's a string, we don't know. Now, the interesting thing about the unknown type is we can store any value in there without getting errors. So this is all allowed. If I now compile my file here, you see I get no compilation error. So thus far, it's the same as if we wouldn't have assigned a type here, and hence we have the any type, or if we would have explicitly set any as a type. But still, unknown is different to any. This here works, but we'll run into issues if I have another variable, let's say username, which should be a string, and that's uninitialized here, but then here I want to set username equal to user input. Now you see we're getting an error. The type unknown is not assignable to type string. So username wants a string, and of course unknown is not guaranteed to be a string. Here I assigned one, but that's just the case in this line. User input technically could hold any value because it's unknown. Now the interesting thing is if I switch unknown to any, this error goes away because any is the most flexible type in TypeScript, and it basically disables all type checking, and TypeScript just says, I give up, do whatever you want. Unknown is a bit more restrictive than any. With unknown, we have to first of all check the type that's currently stored in user input before we can assign it to, for example, a variable that wants a string. So since a string is wanted here, we could check if type of user input is equal to string, and TypeScript will detect this check and understand that in here, what I store in username, because it's inside of this if statement where I check for a user input being of type string, user input is guaranteed to be a string, and therefore I can safely assign it to username. So I need such an extra type check here with unknown to be able to assign an unknown value to a value with a fixed type. And therefore unknown is the better choice over any. If you know, I can't tell exactly what type I'll store in there. It might be a number, it might be a string, but I know what I want to do with it eventually. Well, just add an extra check to make sure that what you want to do can be done, so that if you want to work with a string, you have a string and you're good. And then unknown is better than any because it makes sure that you're not allowed to do everything, but you have at least some type checking. Of course, if you have a chance of knowing in advance that user input is always a string or a number, well, then you should use string or such a union type instead of unknown. So unknown still is a type you shouldn't use all the time, but it is better than any for the reasons described. The last interesting type I want to show in this module is the never type. Now we saw a function that returned void, so that never returns anything. Never is another type functions can return. And that might sound strange. Let's have a look at how it works. Let's say we have a function generate error. Here I expect to get a message, which is a string, and maybe some error code, which might be a number. Now inside of this function, let's say, we throw an error. So this should essentially be a utility function that generates error objects and throws them. So here we might throw an object, which we can do in JavaScript. We can throw any object or any value as an error. And that should have a message property in which I store the value of my message argument here. And I want to have an error code property, let's say, where I store the code argument in. So now this would be a valid function, and we can call this with an error occurred, for example, and a code of 500. If we do that and we compile this file here, we see that once this reloads, we get our error, well, as an error here. And this might sound pretty abstract, but actually it isn't. Having utility functions like this would be pretty standard in bigger applications where you don't manually want to throw an error in 10 different places of your app, but where you want to reach out to one convenient function that builds the error object for you and maybe also throws it immediately so that you can call this function with different inputs, but you always have an error being thrown. Now, the interesting thing about this function is it does not just return void. I actually can specify that it returns void, because of course it returns nothing, but actually it does not just return nothing. If we're totally honest, this function returns never. This function never produces a return value. If I would try to store the return value here, and I console log result, and I then compile my code and this executes, we see there is no undefined being logged here, because since an error is thrown, this essentially crashes our script, you could say. It cancels our script. And this will always be the case for this function. Of course, we can wrap it in try catch so that we can still continue in the script, but this function essentially never produces a value. This function always crashes the script or this part of the script if you're using try catch, and therefore never returns anything. And hence the return type of this function actually is not just void, but also never. Now the interesting thing is, if you hover over it without assigning never, you see the inferred type is void. Also because never is a newer type. It's been around for some time now, but it wasn't built into the first versions of TypeScript. And therefore void is typically assumed, and it's not horrible to leave it at that. But you can be very clear and explicitly set never as the return type to make it really clear that this never returns anything. So from a code quality perspective, this might be clearer regarding your intentions and make it really clear to other developers reading your code that this function is intended to never return anything and to essentially crash or break your script or that part of the script. Another function that would never return, by the way, would be a function with an infinite loop. So if we have while true in there, that creates an infinite loop, and that therefore also would be a function that never returns. The error function here, or the function that generates and throws an error, probably is the more common use case though. So never, also an interesting type which you can use on functions for cases like this one here. Now with that, we had a thorough look at all the core types and the TypeScript basics. You hopefully now understand how we create and assign types, how we assign types to variables and to parameters and why we do that, how type assignments in TypeScript differ from JavaScript type checks, that JavaScript uses runtime types and TypeScript uses static types that matter during development, that the built JavaScript code, therefore, does not include any type assignments. It, of course, includes any type checks because that is regular JavaScript code, but something like this here, this is simply not allowed in JavaScript. This is not supported syntax. That's TypeScript only. So that's hopefully clear. And then we had a look at numbers, strings, booleans, at function types and setting return types, argument types, and also describing the type of an overall function, which can be helpful if you want to have a variable that eventually holds a function. We had a look at objects and arrays and enums and how that can be interesting and help you. The same is true for tuples. And now we also had a look at aliases, type aliases, where you can merge complex types into aliases which you can reuse. We had a look at literal types and union types, which can be useful for scenarios where you expect more than one possible type. And now at the end, we also had a look at unknown and never, which are niche types, but still in their niche, they can be very useful. And now with these basics, we'll dive deeper into individual aspects and of course also explore other types and JavaScript constructs where TypeScript can be helpful.